Hello, welcome to the stream. I realized watching some other streams this week that I should have some like cool intro music or something while waiting for people to join on, make everyone else wait, and then when I actually start, instead of me having this ramble that I like to do at the beginning of every single stream. I've been actually thinking about the way I approach streaming a lot. Obviously, when I got started, I just got the cheapest stuff I could possibly put together and go with that, using StreamYard and whatnot. But maybe at some point I need to actually get some better equipment here. And also been thinking a lot about the format. I've been doing a lot of 3-hour streams, really big deep dives. I think you probably benefit from being a little bit more focused, maybe make the streams a little shorter. So we'll see how that goes. I have a tendency to want to answer every question someone throws at me. So we're gonna try our best here, but I'm just come say hi in the chat if you're here. I'm just gonna get started in a minute to give some people some chance to join on. Pretty excited to kind of show off what I'm showing off today. I've been meaning to make a demo like this for a while, and I suck at 3D, and for some reason all the demos seem to be in 3D. I don't know why. Everyone's doing these crazy 3D demos, and I'm just not the best at 3D. Hey, welcome. Awesome, got some people coming in. Yeah, I'm not gonna wait much longer here. Just gonna dive right into this week in JavaScript, I think, before we get much further. So start every segment usually just going over my Twitter feeds. Usually there's a lot of stuff going on, surprisingly. But this week, I don't know. It was kind of calm. No, there was huge news. React 18 is going to beta, and while that might not affect everyone, because beta, I'm pretty excited about this because you have to figure React 18 has been coming for a long time. I know 17 only came out last year, but realistically, React 18 has been, the promised thing since basically React 16. They knew the second that they released at 16. So you can imagine they knew maybe up to a year before they released React 16 that they were starting on a journey that's going to take React in a completely different direction. And, I'm not going to dwell too much on the features today for this because obviously many of you are already kind of familiar with them, partially because they've been coming for such a long time, and also because if you've been using Solid, you've been using many of these features for the last 2 years. Okay, that was a little bit of a snipe, but in general, though, this is really exciting stuff, and probably my highlight for this week. This isn't React server components for people might get confused. This is mainly around streaming and suspense and kind of unifying the story between server rendering and client rendering. This is all part of a single story. Once you realize that suspense, which we've been kind of using a little bit for a couple of years now with React and lazy components, actually started as a mechanism for streaming. That was why they developed in the first place. You start picturing how this whole big puzzle kind of came together. What else is big this week? Netlify raised a Series D with $105 million. That's another deployment target. I think Vercel raised something similar. Was it a Series C or something not that long ago? We're seeing hundreds of millions of dollars going into these deployment platforms. This is a hot area, and this is only going to grow. For Netlify, you see that they've been doing acquisitions, and you can see that they're looking to really expand their offering, make things easier than ever, and that's pretty exciting. A few other things kind of maybe more kind of glossed over. Tanner Lindsay kind of start pushing new React location or a router based on the TAN stack that he's been building. I think it's interesting. It had he really put a focus on the search parameters and or query part of the routing, which you don't actually see in many other routers. It's kind of interesting because we had React Router a couple weeks ago too, and Remix is going to be open sourced, I believe, this coming Monday. So like we're seeing this movement here, and even with React 18, there's a lot of different ways you can create a React app and approach it mentally. Because I was actually bugging the guys, kind of like poking at the React Router guys, because I was trying to like, how do you solve this problem that I've been trying to solve with Solid App Router around basically preloading and all that stuff, because we have parallelized fetching and nested routing just like React Router, except streaming makes things a little bit more challenging. And basically I found out my answer. Remix and React Router are not actually don't care about suspense or that whole mechanism. They preload stuff before you do any rendering. That's their recommended way. I thought it was interesting that Tanner's router had the similar nested routing, but also has the non-blocking suspense-aware approach that we were doing with our router. So like there's different things, but then like React Query is kind of perhaps a bit at odds with the way that transitions work in terms of like SWR might not be the best pattern. So like we're going to see some interesting different approaches to these kind of meta frameworks before this all kind of boils down. Because I say React's definitely kind of going one way. Remix is kind of over here. Maybe TanStack's kind of down the middle, and that's not to mention how Next.js or all the other stuff comes in. But anyways, I've been talking a lot of React here. That's because, that's where a lot of the interesting news has been. Beyond that, this week has been a lot of just, how should I put it? A lot of just the Twitter noise. Dan Abramoff did a AMA, which I thought was really interesting. And of course, someone asked, do you see SolidJS as a threat? Luckily, he didn't answer, because I honestly, to hear Dan answer that, I'd probably be a little, but I fielded that one and basically explained how every framework has its own merit on its own purpose. And even if they have overlapping features, it's not like they can, especially in the case of Solid, we can't just supplant React because we aren't actually the same as React. But probably the biggest conversation for me this week was you could hear it in my voice. I was kind of a little bit exasperated. There's a kind of continuation of these conversations that have been going on, like the one that happened last week about React hooks and versus Svelte and all this stuff. And someone was like, if you really want a new paradigm, no virtual DOM, but with hooks and immutability, look at SolidJS. And then Paul Henschel, creator of React 3, and also kind of the voice behind all those 3D demos, like the Cube demo that first got me onto Twitter in the first place. I was like, without a VDOM, you lose the ability to schedule. The VDOM solves most critical bottlenecks on the web load. React is not beholden to it. It can go beyond the DOM. Without the VDOM, you can't. 15 milliseconds per frame, slow paint, a slow DOM is the baseline of the horizon. And I'd had enough. I just called him out on it. I said, this simply isn't true. I wish you would stop spreading this stuff like about non-VDOM architectures. And that's a little harsh, admittedly. But this is not the first time we've had this conversation. And responding directly to something about Solid to say basically what we can't do, I'd basically had enough. This goes on for a thread where I literally explain like, where is it? Yeah, like it just keeps on going. Like he asked this question, and that's what I'm going to actually. If you get served 100,000 items, would Solid render as much as it can before the framework threaded, and then either defer or keep existing nodes or not? Scheduling React events, that does not sound like what React's doing. And I go on to explain this, and honestly, after writing all this, I felt kind of terrible because I was like, man, no one's going to like this explanation. In fact, I tried to explain this at React Finland talk. I don't know if any of you have seen this.
How does the term concurrent rendering make sense here when you directly update the DOM? Do you somehow store effects to apply?
Yeah, actually, the truth of the matter, this is all queuing and scheduling behind it. One of the biggest innovations, I guess, with Solid on this side is that the React has fiber internally, so you have all these fine-grained little updates. Solid's hooks are already fine-grained. So we can just go, oh, this is an effect, and you're in a transition. Just stack those off and cue them when the pure computation part is done, right? We do the fetching, like say the resource fetching. I'm going to cut myself off here, and we wait because honestly, no one understood this explanation. See, Paul, here's Paul in the background, still not understanding this explanation clearly. So clearly, I did a pretty poor job at explaining it, and that's why I wanted to do this stream. I wanted to really show how we can do it, because like Paul's not the only one. Block DOM, if you've heard of recently, I kind of promoted it, is a really fast virtual DOM, the fastest that I've seen. They actually use the same cloning technique we use in Solid, and if you go to like the JS framework benchmark, yeah, why not? Let's just pull this up for a second so you can see what I'm talking about. They're like we're neck and neck with these guys, like, or with this framework. Like, look, Solid, Block DOM, 106, 106, like literally next to each other, like pretty much tied. I mean, Block DOM actually averaged out, I guess, like fractions of millisecond ahead to be ahead here, but essentially the exact same performance as Solid with a virtual DOM. And I always knew this was going to happen because, let's face it, virtual DOMs aren't innately slow as much as people might want to tell you. But again, there's this little blurb here. Why would you need a virtual DOM in the first place? Well, it depends on your needs. Clearly, some frameworks can do very well by using other strategies. However, some frameworks, such as React and OWL with their concurrent model, need the ability to split rendering processes into two phases. So we are choosing to commit a rendering, to commit a rendering or not, for some reason, is no longer useful. In this case, I do not see how to proceed without a virtual DOM. And yeah, in terms of perhaps getting rid of a render that's no longer useful, yes, virtual DOM is useful. But in general, it's not, I'm going to show today that concurrent rendering doesn't require a virtual DOM. I have enough experts telling me that this isn't the case, but this is not the first time. People told me JSX wasn't analyzable, that you couldn't, you couldn't do compile time away framework thing with JSX. They're wrong, and they're wrong about this. So that's what we're going to look at today. So what I'm going to do first, because I know obviously I could explain how all this works, but and I will, but that's a little bit much. You probably want me to start with the demo, right? Let's see what the hell I'm talking about, right? And you might have seen some similar demos before, but I'm gonna jump over here. 1 second. Let's throw something up here. I start using these banners. They help me divide the video later, but let's look at our demo here. And what I did was, back in the day, one of my favorite demos was this demo by Jeremy Ashkenas, which is called the circles demo. I think I showed this during the benchmarking the benchmarking stream, but I mean, there's not much to this demo. You can see there's some circles animating. It probably comes in a lot worse over the stream, but there's some circles and there's some numbers and there's some colors and they move. And the reason I choose this demo is because, I mean, it's a little bit shaky here on the stream with me all zoomed in, but if I up the number of circles here, it doesn't really, I'm not really straining the rendering much. Like, let's go up to 500. Like, it can handle this, right? Back in the day, this was actually pretty hard to handle this many circles. The processors and the computers and the frameworks, the JavaScript weren't that fast. But today we can handle this pretty easily, right? But I'm choosing something like this because it's, and I'll get into this more later, no amount of scheduling can make up for slow hardware. Okay, that is rule number one, and why I think that in terms of like our approach to Solid isn't really compromised by not having a virtual DOM. Okay, so anyways, yeah, obviously we can easily handle this, but let's do something a little bit more fun. This example, just for people who want to kind of dive into it to understand a bit more how it works. And I can just, I'm going to post in chat here in case you just want to see this basic example, although I'm going to do more work on it as we go. But here we go. I posted in chat. Essentially, and this might, essentially what's going on here is we have our app, and in our app we have this. I use some pretty poor naming here. I apologize, but essentially this S is the number of boxes. This C is the count that's going on in the middle. And then these are the actual boxes themselves. And then we have an animation loop where we just animate the boxes on ticks. And then we have an interval, a separate one, where we update the count in the middle. And this, I kind of modified this to kind of resemble this Sipirski's triangle demo, which in that demo, essentially the number is separate from the animation. It's just trying to show you, maybe some heavy calculations are going on and you need to show that, but it's less important than keeping the animation smooth. And our animation is very simple. It's just using sine and cosine to kind of spin it in a circle based on some global counter. So essentially this is a pretty simple demo. And as I showed you, we can handle it no problem. But let's make this more fun. Instead of props.count here, let's change this to a memo that adds a slowdown. And if you saw my previous stream on Sipirski's triangle, this should be fairly similar looking. And what we're going to do is see, I'm using terrible naming. Let's call this, let's call this count so that it's actually a little bit more human legible. And let's change this props count now to a count function. Okay, there we go. And let's refresh this just to be sure. Thank you, Code Sandbox. Okay. Now, nothing much changed. It's still going. Well, that's because there's only 20 of them. Let's do 50. Still good. Let's do 100. Starting the glitch. Let's do 500. Hopefully you're seeing it glitch now every time it turns, essentially. And this is kind of what happens to your app when you have like a lot of calculations going on, right? This is simulated, but essentially we're doing something really expensive that we're calculating in the app. It has nothing to do with the rendering. The thing can render itself fine. It just can't handle this. Every time it goes to update the number, this count, it's interrupting the animation because it can't handle this. So I've enabled scheduling in this example. This whole topic that we're doing today is behind an opt-in flag because it basically costs an extra kilobyte of JavaScript. And I don't want to impose an extra, like, I think it's a little more, maybe 1.5 kilobytes of JavaScript on people who don't want this feature. So you can simply just, if you don't call this, Rollup is smart enough to code split all the concurrent rendering, not just concurrent rendering, but the concurrent scheduling right out of the core automatically for you. So if you import and call this function, it adds the JavaScript. If you don't, the JavaScript is automatically tree shaken out. And honestly, for people to tell you that tree shaking like is whatever, this is a prime example of the power of tree shaking. Now, what we're going to do now is let's see if we can make this better. What we can do is we can lower the priority of the count in the middle here. And the way we do that is back here where we set this interval and update the count, we can put this in what's called a transition. And this should seem familiar to anyone who's used React because it is the same API. We just go start transition React. Now, thank you, Code Sandbox. Okay, so what you're going to see here is, again, but let's jump straight to 500. Oh, it's now smooth. The numbers are updating and we're not doing it. And the reason for this is we have actually lowered the priority of the count and it's being rendered off screen. We'll explain that more in a minute here, but now the updates are fine. But this wasn't Paul's question. Paul wasn't asking if we could update like this. Paul was asking if we could handle load. And if you look at this, this is not handling load. When I go to 500, it's going to freeze for a second. See? Watch. Pause. Even going from 20 to 100, my M1 is fast, but to 500, you can see that pause, right? Hopefully everyone can see that pause. Okay, actually, Code Sandbox is doing some garbage, but okay. Let's go here. Bang, pause, and it continues. Hey, Theo. Yeah, so what can we do about this really annoying pause, right? We want our animation to be smooth, even when we just dump hundreds of things on ourselves with heavy computations. Well, The answer is, where do we do that dump? Oh, here, when we change the select. Well, guess what? We can wrap this in a transition too. Start transition. And let's see what that does. Okay, so thank you, Code Sandbox. Now watch what happens when I jump to 500. It didn't jump to 500 right away because it had to do all that work, but it did when it was able to. Let's watch this again. See, the animation never stopped. It did the processing in the background as it could, and then it showed the rest of the circles as it was able. And that's kind of why people are excited about this concurrent rendering. This is not 3D. I'm sorry, it's not as cool as 3D. But what I've shown is I've taken this slowdown where we're basically every single update and every create, we're putting on almost a tax of a second. I'm trying to think of how much processing here. Let me look here. I just stole this from Sapirski's bench. I guess it's not that much, but we're putting this tax on every single cell here. So every time it's created, every time it's updated, and by setting transitions to say that, hey, when we add boxes, that's lower priority, and when we update the number, that's lower priority, we're able to do this smoothly without interrupting our animation, even if it takes a little longer. We don't care if it takes a little longer, right? If you're going from 50 to 500, like, it's okay. It takes a little bit longer, but nothing is interrupted. And that is essentially, that's the demo. Like, that is concurrent rendering. Watch, I'll go back. I'll turn off scheduling for a second and show you one more time the difference. Let's go from 20 to 500. Okay, no, sorry. Okay, maybe let's see if I can, sometimes, yeah, here we go. Watch, this is what happens when you don't have this scheduling. Now, there's a few schools of thought here, obviously, but because React has this feature, Solid has this feature, Free, BlockDOM, or OWL, and a few others have this feature. But why? But Vue and Preact opted out to not have this feature. And the main reason is, and this kind of explained, it's only, this can't change the speed of your hardware. What we're reducing is the cost of this expensive memo that's just cascading. And, like, let's see if we can stress this a bit more. Maybe we should make the drop down also go to, can we add let's stress this thing a bit more. Let's make, what, 20,000? Let's see if we can do 20,000. Okay, let's refresh. Okay, 20,000 is too much for Code Sandbox. Okay, let's try 10,000. See, it's slowing down now. I'm hoping that it actually completes eventually, but what I'm getting at is we're hitting the limits of the hardware. No amount of scheduling, it doesn't matter what framework you're using, is going to get past the limits of the hardware. Because like, even if we, turned off, like, this will eventually pop in probably, but even if we turn off scheduling, turn off slowdown, and I probably, let's see if I can get this. If we turn off scheduling, turn off slowdown, like, the hardware just can't handle this. It's just too much processing. And that's sort of what my point is here. And we'll understand this more as we get into the details. So hopefully, anyone have any questions about the demo so far? This essentially was what I wanted to show. This basically shows how we can basically handle expensive workloads in the background without interrupting the main processing using fine-grained reactivity and no virtual DOM. Okay. No questions so far. Okay, that's fine. Let's kind of scoot out here because I'm going to start a little further back to kind of explain what's going on here. And I'm going to start this a bit because I keep on focusing on the fact that we don't want, or that the hardware, doesn't have any effect on this. And the reason is because we want our execution to be glitch-free. This is very, very, very important. And why the scheduling is special. Okay, so let's talk about glitch-free for a minute. This is a stupid example, but I took the solid playground, and let me blow this up a bit so everyone can see it a little better. I took the solid playground. This is like the standard counter that we probably use on like every single thing almost, except I made one difference. Now there are two signals. There is A and double A, and A times 2 equals double A. And to no one's surprise here, if I click this button, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. It's consistent, right? And you know, that's what we use UI libraries, no big deal. But let's do something a little bit more fun here. And this is what I kind of want to get at. Let's put a timeout around setting double A. You can do this with fine grain. I've shown before how every cell, every text thing is like handled completely independently, so you don't have to worry about this. But let's delay it by a second, okay? So now when I click it, sorry, refresh this. I click this. 1 times 2 is 2 until it's not. Okay, sorry, something a little bit weird. Why is this not updating? Sorry, let's see why this. I was doing this a ton earlier. Let's just refresh. Oh, duh. Sorry. It's funny because I had this all set up earlier. One thing we have to watch out for, obviously, is in a timeout we don't have the reactive tracking in the scope. So yeah, sorry. See, second, 2 times 2 is 2. There's a certain time period before the button updates to the result, and during this time period, it's inconsistent. Now, obviously, you're like, well, it's async. Of course, it's inconsistent. But what if this is a price? What if this is some calculation? You don't want to take something as a source of truth when it's not. And you know, let's see what happens. I do like this. Yeah, it's funny. It's just delaying. Yeah, let's actually make this still read from A anyways, just for the sake of it, so that if I click it fast, it just jumps to where it is. Yeah, okay, cool. So essentially, once you introduce this kind of timeout, things are no longer consistent. And this can be problematic, as I mentioned, because if you have things relying on the consistency of your system, you like, this is the easy job. Like if you've seen like, I think I've shown this demo before, the one with the cubes. Everyone's seen this silly demo. Like there's real hardware constraints. When like, sure, up to where, let's start over again, sorry, up to like where about 3,000 blocks or whatever, we're at 60 frames per second using Solid to render these cubes. But when you get up to like 8,000, it's a lot lower. We're only at about 20. There's real hardware constraints. So how do you get around it? Well, one thing you can do is only update half the blocks half the time, right? Make them jump further, right? Kind of alternate your processing. And that's kind of like that timeout that I was showing you. You can, do some, or maybe when you're adding blocks, don't add them all at once, add them in chunks, but you will visually see the tearing. And that's essentially what I'm showing here. Like this is tearing. 14 times 2 is, sorry, let's start over again. Like 9 times 2, okay. Well, you can see that delay, right? What concurrent rendering aims to solve is being able to delay this stuff but not cause any tearing. And the way it does that is it just doesn't do the side effects, essentially. So if something's heavy on the hardware, like the rendering, well, concurrent mode isn't going to help you, because essentially it's just going to do all the calculations. And if those calculations are dirt cheap, when it goes to render it, it's still going to get snagged. You just told it to render later. So you just slowed everything down, right? You instead of blocking earlier, you're blocking slightly later. But essentially, that's all it's doing. And it's super important to understand that detail. And at the React Finland talk, I actually kind of showed this slide here, and I think this might help kind of understand the similarities and the way that Solid can work very similar to React, because all actions start with some kind of event, some kind of action. Someone clicks a button, someone navigates somewhere, someone tries to do something. But on the React side, that we've all seen this, you set state. Then you have this part where you do the pure computations in React, which is actually the rendering in React. The whole render functions are pure. They're not supposed to have side effects. You can call out use effect, but that kind of gets stashed away to happen later. Essentially, they are confident that they can run your React component as many times as they want without any side effects. It won't affect the outside world, so they can build it, throw it, take it down, do whatever they want. Then afterwards, they take your tree and they diff it with the previous tree and they apply those changes to the DOM, right? And then finally, they run those effects to queued up. And the thing is, in Solid, and I know this is a repeat from my previous thing, is like we have the exact same steps. The only difference is every step is expressed by a specific primitive in Solid. So, I showed create memo there. Like that's where you're doing your calculations, right? In Solid, everything, the components don't rerun. So all the expensive computations, all the logic you're doing, they're going to be in hooks. And those hooks can run purely as long as they're not the effect hooks. So what actually happens in Solid, as I showed before, is our rendering is also just an effect hook. So from that perspective, like if you have like a reactive graph maybe, and you have a signal, right? Like let's make this, because I don't really care, maybe fill it in green. And then that signal has maybe some memos or whatever that listen to it. Let's add a thing. So let's add a couple of these suckers on here. Essentially, and if we go even further, and maybe there is some effects that listen to those over here. So you can see my awesome Scala draw skills here. And we can draw some arrows in black. Why not? Essentially, like go there, and maybe another arrow from here to here, and another arrow. Maybe this arrow goes to here. Maybe this arrow goes to here. Who knows? Maybe this arrow goes to here too, right? My point is, we've got this kind of graph going on with the React system, and we have these signals, and then we have these like memo computations, and then we have these effects, and sometimes even this goes all the way to well, I probably wouldn't go through to there, but sometimes this goes directly to here as well. So, I mean, there's a few things, but what essentially happens is when we have a couple buckets down here. We have bucket here for, I'm going to call this the effects bucket, and then we have bucket here, which, oh, sorry, my Scala draw skills are lacking. We have bucket here, which is, okay, so we got our computation on our effect bucket. So all that ends up happening is when you update the signal here, it goes, okay, well, I'm going to notify these guys that they're going to update. or potentially update. There's a little bit of a game here that it's either they either will update or could potentially update. And then these ones are going to notify these ones as well. And all we do is while we're queuing, we just go, you go in this pile, you go in this pile, right? You're like, okay, like, let's give it a dotted line. Like, okay, you go here and you go here. And you can tell they're already color coded. They know where they're going. And you go here and so on, right? And I mean, this is pretty simplistic, but you can immediately see we've got two queues going, and then all we have to do is when we're running under a transition, we just go, okay, well, don't run these until everything is done. Don't run these. You can run these red ones as many times as you want. If green changes or red causes another red, like I missed it. You can have some reds in the middle, but essentially they just go in two buckets and we just don't run the blue ones. There isn't really too much more to it than this. So we have clear separated things. And so all that the enable scheduling does is it may, instead of running this queue synchronously, it just goes, okay, we will use idle callback. Actually, Solid uses React's scheduler, a kind of minimized port of a React scheduler to actually do it. So we actually use this very similar scheduling algorithm that React uses for their concurrent rendering. I actually pretty much straight up stole it. So, cheers to React. And in that sense, we have the ability to run this as much as we want. And why this is important is, I'm not going to turn this example here into suspense, but what I want to highlight is that we can essentially hold off applying A in a visible way until AA is ready. Thanks. Right? That's the whole thing. What if I click this as many times as I wanted, and we just knew that at the end the sum would complete? And the thing is, this is common for things like navigation. Like, you click on a new tab, right? Do you show that you switched the tab yet? Or maybe you want to show pending state, but one thing, like, here, there's a delay here. I'm going to click on this tab, and you're going to see a delay before we show tab 2, because we're loading something while tab 2 is loading. In order to load tab 2, we have to actually render it, and the data has to be updated, and the fetching and all that has to happen. But tab 1 can kind of stay for a bit while it's doing that, right? See, it didn't change right away. When I click dose here, there is a delay before it switches because we hold everything. We wait till it completes. And that async consistency is why we do concurrent rendering. So, and what my silly little drawing here is showing how you can do this without a VDOM, because events can be scheduled. I mean, that should be no surprise to anyone, right? Events can be scheduled. So essentially, and the thing is, okay, so you're probably thinking, okay, well, what about those real DOM nodes that you're using? How can you like deal with that and all this stuff? Well, the thing is, in our example here, our scheduling example where we have our circles, otherwise would have kind of tied everything down there. It has to interrupt, right? Like, when we made that switch here, it took so long because it started working on those circles in the background, but then it's like, oh no, I have to update the animation. And then it's like, oh no, I have to update the animation. So in React, the way that works right now, and they talk about changing this in the future, is they try and do as much processing as they can. And then when they get cut off, they're like, oh, well, I guess something else is more important. And then when that something's done, they start over and do it again with the new information. And essentially, every time it interrupts, they have to start over again. So they interrupt. They don't have Resumable yet. They have talked about it, but essentially they interrupt and they restart rendering over again. And that's fine because it's background. It's not going to be a big deal. But it means that if you're harsh enough on it, you can actually kind of cause starvation. They do have like an upper limit to prevent that. But essentially, it really turns into a form of debouncing in a sense, right? Because like it's like, oh, you typed another character, I gotta wait again. It's that kind of mentality. And don't get me wrong, Solid is the same way too, to a certain degree, because if new updates come in, well, you have to process those new updates. So it's you can always kind of cause the starvation to a certain degree. But the key difference with Solid is we're fine-grained resumable, and that is pretty cool. Okay, and if you want to see what I mean by that, check out this little example here. I've used this example before, and this is kind of a silly example. I'm just creating an H1, and then inside there's a P2, and I've wrapped it in this delay component. What does the delay component do? Nothing special. It basically, I know this looks a little bit, it's because you can't set a function with a function thing, but essentially we have a timeout of a second, and at that point we set the signal to the children, and we return that signal. So essentially what happens here is when we first render, we don't render the children, and then we wait a second and then set the signal to the children, and that's what we actually render. So when I refresh this, what you're going to see is some stuff, and then a second later, some more stuff show up. And yeah, you're like, what? No big deal. I'm sure you can do that in any framework. Of course you can. But my point is, Solid's fine-grained, and I've showed this in another stream, but I don't feel I need to show this again. All that happens when it picks up is it doesn't render app again. It just picks up. I'm not sure 100% on this, but they said no currently. Like that they have to, that they actually have, that like they're working on it, but right now it's not. So those original demos that they used to show up React Fiber actually don't work well anymore. Like this, I think the Sierpinski triangle. They focused on the IO stuff, which is, to be fair, what I'm going to get to in a minute, what I also focused on. But I mean, I can probably pull up Dan saying no, but he's also not the one working on this directly. I think Andrew Clark is. So don't hold me to that completely. But the last I heard, they said that it is not resumable. It's interruptible, but not resumable. Okay, so, but my point is, when this timeout runs and you set the component, all it's doing is triggering that signal, which is then rendering this thing again. It's not rendering everything again, right? And we can play Inception here, right? Let's how many delay components can we jam in here, right? Like, I mean, this is just a freaking stupid, silly example, but oh, there we go. My point is that every time they resume, they just continue where they left off. And this is just fine-grained reactivity, right? We see that the closest effect is the effect that runs. Like there isn't anything special here. So when we pretend this whole thing happened off screen, right? Maybe you're like, because the kind of thing you got to understand here is that this P children was always here, right? Like we all these DOM nodes are always here. We're just choosing not to show them. They get created first and then inserted. And I don't know if the output function is going to show this well, but you've kind of seen this before in my other demos, where essentially we create an element and then we return it, right? That's the whole process, right? You create first, and then it gets inserted on the way back up, essentially, as you compress the JSX, right? Children get created, and then they get inserted in the parent, and inserted in the parent, and inserted in the parent, kind of chains back up. It's the same kind of deal here. So we had all this stuff. So you could picture, if you were kind of making this analogous to concurrent rendering, is we could render this off screen with some async, and then as each async thing comes back in, we just continue where we left off, just draw in the next thing. So, or do the next little piece of update. So we render as much as you can ahead of time. And you gotta kind of got to ask yourself the question here is like, yes, in something like I was showing with the circles or whatever, it's, maybe it's bad to have all these DOM nodes or doing that work ahead of time, because you're trying to free the main thread up for the main thread animation. But let's face it, for most IO, you're freaking waiting. Like you're here and you're waiting. You're like, okay, is it ever going to load? I mean, this is pretty fast, but you're essentially waiting on stuff to load. And what you're doing that, maybe there's a little animation, but for the most part, what's beneficial about this approach is it renders as much DOM nodes as it can ahead of time. It's already rendered most of the screen. The second that last bit of data comes in and updates the last little bit and then inserts, you have the least amount of work left. Whereas with something like React, it's been just doing all the pure rendering effects so that, when it's time to go, okay, now we're going to swap over, well, that's when it does all the DOM work. And I already mentioned earlier that, we're not saving you on the hardware level, right? If the DOM work is expensive anyways, you're not going to be saving. So we have the ability to do more of the DOM work up front, and actually for things that like this actually cushion the blow of basically doing, page or section re-renders, because sure, we can schedule it piecewise, but we also do it as soon as possible. So when it, at the end, it comes in as soon as possible. Now, as I said, there's trade-offs there. I'm not going to say that's a pure win, but I've shown how we have a concurrent model that actually works quite similar in a sense to React, and essentially possibly has some advantages in a certain way. And like, let me go back to Scala Draw here for a second, because yeah, as I like this image, but maybe we can move on and do a different one. Let's just trash this one for a second. Okay, let's clear this. Just so you have a real visual of what's going on here. Like, I know I already showed the tabs example, but and I hope my explanation is clear. No one's writing anything in the comments, so hopefully what I'm saying is making sense. We have our app, and then we have our navigation bar, right? And then we have our content. And this is like a more typical IO scenario, right? And essentially, beside it, once you click on that one tab, once you go, okay, I'm going to click on this button here, right? You click on this tab. Once you've done that, well, Solid, and let's say it swaps out this content in the middle here. Solid already has, this is what's happening off screen. Solid doesn't need to do anything special, because this outer circle is already there. This tab bar is already there, and the button and everything is already there. So the first thing that it needs to do is it goes, okay, well, now that this button chat has changed, I'm going to try and draw the new content here, right? And it's going to create new DOM nodes while it does that. Sure, it's kind of scheduled and broken up. Like, it will go as far as it can, just like I was showing in this demo where it can pause essentially. But it's going to start, it's going to start creating it. It's going to start creating it as it can, and then essentially you're still seeing this. So it's fine. You can have I'm not a great artist here, but you can have like some fun spinning thing, or going on here, or some animation or whatever. And this over here is in fact doing its thing piece by piece, and then when it's done, it just swaps it in, right? And even if it's on the same page, we can do this. There's basically a little bit more detail here that I haven't completely explained, but essentially the key to the whole transition thing is we do have these buckets, and then the other part is we actually fork reality. And I know this sounds crazy, but essentially, because we know the signal change and we know every downstream dependency, we have the ability, we can go, okay, well, this is fine, and this is happening in this reality, but we can then like make a shadow version of this over here. You know what I mean? And it can do different, like it can kind of maybe like the graph's more complicated, but we essentially can do parts of it and then merge them back in with the original. So this is how how both pieces work. We actually don't even really have to merge this part. This part merges in at the end, but essentially we can basically, like a VDOM, essentially sketch pad out the pure part of of this, right? We can just keep on running this. Oh, this gets a new value, run these again. This gets a new value, run these again. And we're working on this all to finally merge with this. And the way that we do this is anything under a transition gets applied over here on the transition side. But if someone updates something that is not under a transition, if it's not related to any of these nodes, it's just going to run as normal because who cares? But if it is related to the nodes, we just kind of go, oh, okay, well, obviously a direct relation like this is a bad example, but let me give a better example. Pretend we have another node right here. Okay, I'm going to make another signal, right? And let's make it stroke. No, we're solid line. We're making another signal here, okay? And this signal points at one of these other ones that we care about. Now, when this one updates, like this is the one that caused our async. Maybe this is our async event or something. This is the one that caused the trouble. But when this one updates, you see that it affects this node. So all we have to do is basically, let me see if we do this, transpose this over here, essentially. This doesn't have to be part of this thing necessarily. It's more like a virtual kind of transposition. Let's do this there. More like this. But essentially, when things happen outside of the transition to our nodes, we apply them on both sides. This way, things progress as they move forward. Like we're merging as we go, so that at the end we can do the full swap in. So as I said, this is part of doing as much work ahead of time as we can. We do isolate the transition, so any transition stuff happens in the transition timeline before swapping in. But because stuff can still happen to this timeline, we apply it to both sides. And again, because this is non-blocking, at least with scheduling on, it's not a big deal. That hopefully some of that makes sense. Let's see, we got a few more comments now. I'd done this with React portals to maintain state in some really weird state management stuff in Twitch. That's cool. I might have missed the context because I was talking to myself and I forget which part this would refer to. But yeah, Theo, if you want to clarify, go for it. Discussions will include writing docs, yeah. Can you talk more about scheduler interrupting? Yeah, okay. Yeah, this is actually, maybe I have to show a little code for this one, because I do want to get there. Yeah, let's look at this for a second. Yeah, actually, sorry, Theo. Yeah, you're right. You mean like using a portal to kind of like do some stuff to the side and then bring it in. It's fun. It's like double buffering. But and the thing, just in case anyone wants to know, and I know this from benchmarking, DOM creation is expensive, but attaching and painting is almost equally expensive. It depends on the situation and like the CSS application, but like it's not just the creation of DOM nodes that's expensive, but also the how should I put it? The attaching, like you pay. It's almost like there's a huge amount of cost that goes into painting and layout calculation, and like actually like taking the nodes and attaching them to the DOM. So it's not just the pure creation cost here. In case anyone's wondering. Yeah, so we got a couple of things going on here. Yes, this does do forking. Yes, definitely, and there is some similarities here. Definitely, and the better I get at the transaction model, the more it is like this. There's definitely, I've been trying to clean up the code here a bit, and that's why I'm a little bit hesitant sometimes to show this off a little bit. But it is actually, it's fairly, yeah. Let's go there. It might be simpler than you might expect, because I think to show this off, I do need to show this, but it's actually. Let's see if I can zoom this up a bit, as you can see. And let's go to Signal TS. And I'm not going to go through the whole thing here, but essentially, most places, let's see if I can find update. See this updates.push? This is, there's a place where I want to show, sorry. Yeah, right. When you write a signal, there's this like loop, which is like either push into this pile or push into this pile, like I was showing a few minutes ago, right? But more than that, the way the scheduling works is at the end of running everything, where is it? Complete updates. If the scheduler is enabled, we have the scheduled queue function, and the scheduled queue function is actually just something that we store in the transition, and it essentially is just calling. This is actually request callback or our callback example, but it's literally just calling this request idle callback scheduler. And I could get into details here, but essentially this queue looks at basically a maximum time scope that it has to run, like it has a deadline, and it also listens to if possible is input pending from the browser to know if someone's like actually clicked a button or something to interrupt. And other than that, it's just using a window post message to essentially queue work at the sorry, where is it? Schedule callback not equal null, schedule callback. Yeah, it's using post message communication to try and, that's like the quickest way to do a set timeout, to kind of to concede back to the process, back to the like the main thread. And beyond that, I mean, it is a little complicated here. As I said, I grabbed a lot of this from React. Where is it? Flush work. It's basically just doing this work loop as far as it can, and it just basically is checking against a deadline how much time it has remaining. So you queue up all these tasks, and then it runs as much as it can each time until it gets interrupted. I don't know if that makes a whole lot of sense to people, but we just, as I said, the queues just get pushed, and then when the scheduler is involved, we just almost run them straight into this scheduler queue. I hope that answered the question. It's a little bit technical. The other thing I actually really wanted to talk about here, again, is more focusing on the pure expense of effects, which is that I keep on mentioning that these things don't actually save the work. And I had another example here, but it's actually eluding me right now. When the question came up, I had it in my head, and it's kind of escaped me for the moment. It was more that, I don't have it anymore. So I apologize for that. We take a second to get a little bit of water. Maybe I'm drinking my drink too fast. Probably not. Yes. Sorry, this thing's still running in the background. I unfortunately, I think I lost that point that I wanted to make about the expense of the work, because it's eluding me. Well, this is actually, I was talking about keeping streams shorter and more focused. This is mostly what I want to talk about. I got through everything in an hour, which is good. I don't know if there's a ton more on this. I mean, I've showed the suspense demos before, where essentially we're doing the rendering off screen, and then as it completes, this one that's a nested suspense. You kind of have that control. But I think in terms of concurrent rendering, there's only really two topics. There's the IO scenario, like we talked about with the navigation like suspense, and then there is the kind of like the time slicing thing, which I remember now. Yeah, the time slicing thing. Because I wanted to get back to the topic. Like React has it, Solid has it, Free has it. Why does Vue and Preact and whatever not have this? Why haven't they done it? And why is it behind a flag in Solid? As I said, you have to, like in all of these examples like this, I'm not doing prioritize updates. It's not interrupting, because the only difference between having the scheduling present and not having the scheduling present is just that queue I just showed you, right? Which is why it was good to explain the queue. That ability to essentially kind of push into that like deadline queue. But without that queue, Solid will just run what it can in the background. And for most cases, that you aren't doing crazy heavy stuff. And again, not heavy rendering stuff, because heavy rendering stuff is always going to be slow. But heavy processing stuff while you're doing something else, you're going to be fine. And that was the thing. In Vue's perspective, and even Preact to a certain degree's perspective, they were basically saying that React was doing this to solve their own problem. Basically, they already had, and even I guess Svelte might have not said it, but this is kind of the defense there. Like, you need to be doing heavy work that is not rendering. And the question is, who's doing that heavy work that's not rendering? It's not the framework. Frameworks are actually all pretty optimal. They themselves aren't doing that much. And as I said, the pundits will kind of joke and laugh and be like, oh, it's because React is so slow. They have all that non-rendering processing, the VDOM diffing and that. And maybe there's like a small sliver of truth in it, but no, it's the end user code where that processing is. But the thing is, what leads to that really bloated end user code that we would need to do that? Because like it's hard to come up with these demos. Sorry, where is it here? It's hard to come up with these demos. Like you got to fake these expenses. Like if you've written solid code, what are you writing in a memo that is going to be that expensive? That has nothing to do with rendering, just pure computation and calculation in your app that's going to be that expensive. I honestly don't know. And for most apps, small apps, I think it's fine. See, the reason that React and Facebook care about this time slicing thing more and splitting it up is because if you have an app as big as what you might find at Facebook, something so massive, and you have a top-down renderer, like someone could be doing something stupid, and my guess is that something stupid might not be localized. It has the potential to re-render whole sections of the trees. Device connections on Windows for AVU devices. Thank you. Yeah. See, this is the kind of stuff I'm looking for, right? Because like 3D is another one, right? Paul, who's been really pushing. Oh, is this Windows specific issue? Yeah. But Paul's been pushing this for 3D, and I get it for 3D, definitely, right? If anyone knows anything about React 3 Fiber, it doesn't even use React to update. Like it uses React for the model, but it can't use React's use state because it's too slow. It gets in the way. Obviously I was boasting earlier about how Solid's like cube demo is fast, but like obviously if you just skip the whole framework altogether, that's faster too. But the point is, like for React 3, since they're mainly using it not for updates but for creation, this is amazing because you can basically buffer the creation costs behind the scheduling. So it's expensive to update 3D graphs. Like they tell you not to do that. Not in real time. You don't want to like have basically you gotta kind of recreate most of the graph, and if you're to like have something animate on the screen, you're trying to like add stuff to it, it's gonna chug right down. And Paul's like, React has solved this for me because we declaratively describe our 3D graph using React, and now the creation doesn't affect what goes on the screen. That's why he often makes things like it's faster than 3JS or faster than vanilla. Obviously, when someone tells you that, they're full of shit. But it's a very powerful way of making of making your point, right? Like basically by adding the scheduling layer on with React, they have the ability to kind of mitigate those costs, do things off screen, pull them in. These are the kind of cases where this is interesting, but this is just not the common case unless you're doing really expensive work. And I think the thought here is, if you have an app that's big enough, you don't know all that expensive work. So you can just put something on a transition and just go, look, I don't care. It's not important. Deprioritize it. It's just going to work nicely for me and not have to think about it, right? Like all we had to do was go like, when this tab changes or when you set this thing, start a transition. Another cool thing, is that React actually has multiple priority levels coming in. They have these things called, I think it's called lanes, where they have the ability to set like 3 or 4 different priority levels, right? Solid only has 2. It has normal priority and low priority, but React can actually like schedule like a whole bunch of them. As I said, I haven't hit a use case where this actually matters at all. Like hopefully but you can picture if something is complicated enough, this might have some impact. So it's interesting. As I said, there's these 2 sides to it, because from the navigation IO side, like the things I show with suspense, I think this is like, I knew right from day one, I'm like, this is amazing. Like this is what you want. It's just smoother. It feels nicer. You kind of get this nice transition. On the time slicing side, I don't know who's it for, but it makes a cool demo. Especially, sorry, it's not 3D, but you know what I mean? It's a really cool demo thing. But as I said, I mostly just wanted to kind of prove and show that you don't need a VDOM to do any of this. This is just another thing. And the reason for that, and I've said this ad nauseum in the past, is because reactivity is nothing. It is literally just some events calling some events. So you can make or model whatever the hell you want. You can put a VDOM in reactivity if you want. You can do stuff. It has an overhead. Reactivity is not free. It's just when you use it as a way to avoid creating other systems, it can both reduce code because you're using the same primitives over and over again, and it can have good performance because it's not introducing these other systems. That's the gist of it, right? Like it's almost too simple, right? Like kind of like how Redux is like too simple. So most of my work as a framework author is actually hiding the boilerplate or making the experience smoother. But the core here is, as I said, it's just some signals and some effects. I don't know. Now, I believe I've said everything I have to say on this topic. So I might call this one short if there's any more questions or whatnot. As I said, I want to kind of get things more focused these days, and I think this is the pattern I'm going to do. Basically maybe an hour and 10 of conversation, 20 minutes for Q&A kind of deal. Your diagram, do you want to explain why createComputed is not just a differently trained effect? Oh, yeah. Okay, cool. Yeah, this is a great thing. Because I showed this. createComputed actually happens at the same time as createMemo. If you look at the SolidJS code, which I'm not going to pull up again, it's too much, it's actually marked as pure. And you're like, what? It's pure? I needed a way to do updates pre-render. And sometimes just pure derivations don't work. So technically speaking, in our wonderful drawings here, createComputed actually happens here, like before the effects. So that like the rendering and the side effects and stuff gets held here, but createComputed actually happens in the red zone. It is actually purely red. So this is why there's different ones. We actually have 3 things that look really similar in Solid, and it confuses people, and this is a great time to address it. We have createComputed, createRenderEffect, and createEffect. And essentially, createEffect is clearly on the blue side. It is always blue. It's your side effects. You can see it on the world. createComputed is always red. It's only supposed to update other signals. It's things that basically sometimes you can't drive them as a memo. It happens in the pure space. You shouldn't put console logs and effects in there. It should just update. And then finally, createRenderEffect is the weird one, and it's one of the super powerful ones, because what it does is at creation time, it is treated pure. And the reason for that is it gets created with everything else, because its whole point is to render or create something, but it's not the one attaching. As I already mentioned, the way Solid renders, it renders something first, then returns it to get inserted. No component inserts itself in the DOM. It's the parent that inserts it. So at creation time, a render effect actually runs at the same time as the red ones. So it's all prepped in ahead of time. And then anytime it updates in the future, it's in the blue pile. So it actually changes from being basically treated like red to being treated like blue during its life. And this lets us do the DOM rendering, do the semi-effectful stuff at first. It doesn't affect the outside world. And then if it's already the thing that's fixed in the DOM, already the thing where the insertion happens, it gets held off. So it's a weird split, but it means that each of those three have a very important and different purpose. And while this is super advanced stuff, most end users, first of all, they just need createEffect and signal. They won't even need, and then maybe they need createMemo for some expensive calculations. Then maybe for some synchronization, maybe they have like a form reset, they'll use createComputed. But almost nobody should be using createRenderEffect because, as I said, it's basically an internal for the actual DOM rendering for this kind of create that isn't seen by the world. And even createComputed is not that common. But essentially, all three of these serve a very important purpose. Hopefully that explains it. And hopefully this is a hard topic, and there's a lot of confusion here. I went through that whole confusion because the first demo I ever saw of concurrent rendering was this. Well, I guess it was the triangles, right? This one, which is very similar to the other stuff I showed you today. But then it was this demo, and I was like, what does this have to do with concurrent rendering? I tried doing things to make things more performant, but the tricky part is Solid was already more performant than the other libraries. And then when I tried to figure out how to make it concurrent, I couldn't figure it out because nothing I could do would make it better. And that's because the limitation here is the hardware. So this was a terrible demo. Paul knows it's a terrible demo. He's actually taken it down. You can't find this on Twitter anymore. And he replaced it with a better demo. But you're right. It's essentially this was not the right demo for this. The newer demo is much closer to my demo here, except it's 3D and looks way nicer. But essentially, that's why that's confused, because you think that people keep on talking about it and associating it with performance. So you think okay, if I use this, concurrent rendering time slicing, my performance will increase. Well, only if you're doing really expensive calculations. So often, if you're already using a fast framework, like a non-VDOM framework, you're probably not going to hit some of these things anyways. And I'm not talking about VDOM from the rendering side. The rendering side, VDOM is just as fast. I was talking about the block DOM, but I'm talking about more of the conceptual patterns of getting into full re-renders. It's really about expensive random end user code. Never got what createRender is for. Yeah. Honestly, probably don't use it. It's hard. I expose all the primitives in the docs because literally you see everything that we have that we build everything from. There's I don't know. There's quite a few helpers and stuff, but the core create blanks. There's what I want to say there's 8 or 9 of them. You probably should only be using 3 of them, and that's the same thing with React, right? There's only a couple that you use most of the time, but they're there, and with those you can recreate Solid from scratch, like the renderer. So, there's that. Well, yeah. Well, we can talk about this. Someone from the art community was like, well, I don't get it. You praise Solid, and then you go to say that without a VDOM you can't do any of this stuff. Okay, I'm going to continue here, but I have to address this one. I don't even use context anymore. There you go. Yeah. And to be fair, people have been trying to push me this way on Solid too, because they like these kind of contextless patterns. And there are some benefits for Solid for context. It's kind of weird. It's almost the opposite of React. There's no performance overhead to using context in Solid. And it actually has benefits in terms of being able to keep the reactive life cycle under the tree and under the graph, especially for scheduling of effects and stuff. So I try and push people to context a little bit, maybe too hard. They don't need it for simple stores and all that kind of stuff. But ironically, context is way better in Solid than it is in React. Yeah, I needed to do this just to show people. But I honestly, I'm like, use context. But whatever. Yeah, people like what they like. Anyway, back to this. So what happened was, and I think this is under discussion, someone was like, VDOM use cases, that's harsh. Hi, I was reading the README and the premise of the library seems really cool. I saw in the section about this the paragraph, why do we need a VDOM? It implies that you need a VDOM in order to achieve concurrent rendering. I'm not sure if you guys know this, Solid supports it, blah, blah, blah. You're still doing it, Theo. Anyway, and because I've been telling the community, we've had versions of concurrent rendering, maybe not the interruptible one, but we've had versions of concurrent rendering now since I want to say sometime in early 2019. As I told you, it's been a couple of years. People have been using suspense, they've been using streaming, and they've been using this stuff in Solid for quite some time. And so they're confused when people are like, oh, you can't do it. And essentially he says that it comes down to what you mean by concurrent rendering. And as I understand Solid is doing it has no virtual DOM, but it doesn't maintain an alternative reality by creating the actual DOM nodes, like clone node, and update the actual DOM nodes, replacing the old one when the new DOM is ready. Owl's doing it differently, that's fine. But there's a much bigger difference. All components in Owl are a unit atom of rendering. This means that the content of the component DOM will be updated atomically every time. And this is different from Solid Model. The components actually disappear from the runtime. So once you update two values, one synchronous value and another needs to wait by default. And so you may have your screen updating to display the first immediately, then later to update the other. This means that, okay, yeah. I don't think he's saying that the DOM is bad. He's suggesting here that our default model is like what I showed you here, that our default is when it's async for it to tear. That's our default model here. But like there is a difference, right? Let me get back to here. Like React's default model is to tear as well. FYI, just on the async side, we were both synchronously consistent, but unless you opt into a transition, our default is not to hold it. And the reason for that, it's a little bit tricky, but picture writing a component and updating some state in your component, okay? And it's working the way you expect, and you do some action, update that state, and then later somewhere else, something that generally happens later, you kind of count on that state being updated. Like it's been a micro task. Like that's typically how it works in React. They get queued to the next micro task. So you do some work, and then another action 2 comes in, and you're like, okay, I can count on that being updated. Then someone downstream from you, like does something async. Now, in React's model, so what? Who freaking cares, right? Because you change that state, and same with Solid, it still works the way it does, and that person's doing something async, that's on them. But if you have a model that is always asynchronously consistent, like that's the default, when someone over somewhere else in a different component goes and makes something async, that now it can cause changes in behavior in your component without you opting into it. Like we tried this with Marco, like what he's talking here, and it was terrible. I'm glad people are experimenting with this kind of thing, but it was actually it was really non-intuitive, because like code that updates somewhere else now can change the behavior of your code, because now suddenly it needs to be asynchronously consistent. Now no longer does your value update anymore. It's now been caught up in like a transition, and not even a transition you opted into. That's the challenge if you make everything asynchronously consistent, because most of this stuff is just about defaults, from my understanding, because they don't have suspense. right? When one of the benefits of having suspense is you're like, this is contained to here. We care about it over here. You know, there's this double-edged thing with a suspense where like there's a double-edged thing with suspense where like essentially, how should I put it, like you're kind of, it's not edged, sorry, that's the wrong term. Basically it reverses the flow. It's what was it called, inversion of control, because essentially the child can go, you know what, the parent goes, okay, look, if you're going to do some crazy crap, I'm going to contain it here in the suspense boundary, have the placeholder, have the transition, and be like, you do you, right? I'm just going to filter anything that wafts up to me and sections it off. But it gives the power to the child to go, oh, I'm going to listen to something async or not. And it gives the parent the ability to go like, okay, here. But if you remove that boundary, that ability to make those kind of rules, everything's like can just affect everything else. Like, it's really hard to wrap your head around this sort of async reality, because any change may or not apply at any point, depending on what downstream things change because of it. And I hope that makes sense, but it's like, suspense and having these boundaries are actually really logical way of containment and being able to go like consistent here, not consistent here. And I know that's weird. Like, why would you ever want something non-consistent? Well, sometimes reality isn't consistent. We as beings live through segments of time. If everything was asynchronously consistent, I like like it doesn't, it's not the way think or processes work. Sometimes it's good to have that control, good to have that escape hatch, and good to be able to make sense of your code. But yeah, I mean, in terms of the way I originally thought, I thought he was saying this, right? Because, and this is why I was talking about trade-offs. If you create the DOM stuff ahead of time, then yes, you know, you're doing that work ahead of time. So if you're doing something really heavy, like super heavy, something that would be close to maxing the hardware, then doing that work ahead of time is expensive. Keep in mind, we don't update the DOM completely off the screen. We still hold the effects. It's only the final effects. Like, we create stuff, but we don't update it off screen. That update happens at the end, right? As I said, render effects render once, but on every update, they get held like every other effect. So technically speaking, we just create things once, and we're not actually incurring that much extra off-screen overhead on the DOM. But the more I'm reading it here, it looks like this is more about defaults, and basically how OWL, which is the framework based on top of block DOM, basically delays everything till every component is ready without using suspense. That's my take of it. I think it's interesting, obviously, because there's obviously places where a VDOM has some benefits if you want to throw away renders. Like, if your decision on the offset is to throw away renders, then like, yeah, use a VDOM. Like, when I mean throw away, I mean not resume, not progress, not build towards a consistent future, but literally just like, let's make this and just chuck it away. So there are use cases, like sometimes that actual work maybe doesn't matter much. Like, maybe it's almost like preloading. You're just like pre-rendering a page ahead of time. Like, what else are you doing? You're waiting, right? Like, maybe it's not that big of a deal. It's in the background. So I don't even care that it's DOM nodes, perhaps. But a better example is stuff like GQTY or whatever, the GraphQL library, that literally passes a proxy through the state and basically just fake renders everything to figure out which query parameters you used, and then re-renders everything with the real data. Something like that is like obviously not great in Solid, because like you're rendering everything twice just to figure it out. And another example is server-side rendering. Some libraries like Next classically, although they've moved to React 18 and the good patterns, they just keep on rendering the whole app as long as there's waterfalls. They just, you know, they render so far, fetch the data, render it all again, fetch the data. Like, this was the old pattern that they used to do on server-side rendering, where you just keep on re-rendering your React app, which, you know, is a little bit crazy, especially when React server rendering is not particularly fast, but, you know, good enough. So there are places where like having a VDOM, you know, maybe isn't as expensive. than other options. To be fair, the server is maybe a bad example because Solid uses string rendering, which is faster than VDOM. But like essentially, like there are places where having a VDOM and kind of preemptively rendering and throwing away are beneficial. We haven't seen those situations in real life, and our IO case for concurrent rendering is not that situation. And even our this demo is not that situation, because you want to keep the work you do. You're working towards an eventual future, even with multiple priorities and transitions coming in. Like you're building towards something, and in that sense, I think while it's unclear if in all cases doing the DOM first is better, like it's just a matter of front loading and back loading it a little bit. It depends. If you optimize for navigation, building the DOM ahead of time is better. If you're optimizing for rapid updates, maybe building the DOM at the end is slightly better, But in my opinion, the IO story, the tabs or whatever is the case. As I said, I don't even have this. This is under a flag. I don't even consider. I'm not even sure if we really even need this. I'm waiting to find an example where like this is actually like, other than maybe 3D or something, where this is actually something that is like important to do. But I want to, as I said, the show for like the 5th nth time that you can do this without a VDOM. Okay, what time is it? What are we doing here? It is 5 to 9. You know what? That's like an hour and a half. I think we're good. Is everyone good? Say something to chat. No? Give you a sec. Maybe just see this demo one more time. Watch us take our slowdown, turn off our concurrency, watch how it breaks and chugs along as both it updates and when we go to add the circles. Turn it on. Smooth as butter. All right. Yeah, I hope the drawings and everything helped. I hope the explanation helped. Thank you, everyone, for joining me today. Gonna call it early, get some of my own time back, and hope you guys all have a great weekend.